we're going to be working on Chapter 10 today, starting off with our study on circles. So looking at this, we need to get some good vocabulary down so that when we talk about circles that we're all using the same language. Some of it is very familiar to you, but some of it may be a little bit new. So let's move right along. First of all, a circle will have a center that's not actually part of the circle, but all of the points on the circle are the same distance from the center. So this is what this looks like. If P is the center of the circle, and you can just do a rough sketch of a circle. This is the first year ever I've had actual circles that look like real circles because the tool helped me. P is the center of the circle, and it is equidistant from the points on the circle. So same distance from here to here as it is from here to here as it is from here to here. Second? P for point, okay. You can have all different types of center points, but the center point of a circle is what you use to name the circle. This is circle P, and right here that's how you notate circle P. Circle with a dot in the center and the center of the circle. So if there were a Q in the center, it would be circle Q, or an O, it would be circle O. So circle with a dot, P, means circle P. So you could actually have a couple of different circles that are circle P that are actually completely different circles, but we'll get to that a little bit later on. But for now, you just need to know that you have to have a center. It's the same distance from all the sides, and this is how you notate it. So starting from the very, very beginning. Anybody still writing that down? No?
You got it.
You got it. All right, so we want to get a few different types of segments associated with the circle. Okay, so we'll just start with this one over here, and I'll let you write things down in a minute, but I want to talk about them. Any segment that goes from the center to the end of the circle is called a radius. Okay, like I say, some of these terms are very simple because you've heard them many times before. Okay, please go to your seat.
So simple.
So a radius goes from the center to the outside. You should know that already. This one you might not know. Any segment that goes from one point on a circle to another point on the circle is called a chord. C-H-O-R-D. C-H-O-R-D. There's the word chord. Okay? A chord. So a chord goes from one point on the circle to another point on the circle. It may or may not go through the center. Okay? It may or may not be longer than the radius. Okay, if I had a little tiny chord going from here to here, okay, that could be smaller than the radius. So a chord might be bigger than the radius, it might be smaller than the radius, and a diameter is a special chord. It's a special chord that passes through the center. The center. So diameter is a special chord that goes through the center. So a diameter actually follows all the rules that chords will follow. So here are those definitions I just said in words. Okay, so R is a radius. The end point is on the circle and in the center. Okay. So I could say that PA is a radius. Now you probably won't need to know these by definition, but to recognize them, and it just helps to have the words if you need to double check yourself. A chord is a segment with endpoints on the circle. If I had one that just went like to here and it didn't actually hit the end of the circle, it wouldn't be a chord. It has to actually be a segment that goes from one point on the circle to another. And the diameter goes all the way across and has to go through the center point. Give me a second here. get all that written down. All right, now there's a couple facts that you might remember about radii and radii is plural for radius and diameters. So if you have two circles that are the same circle, in other words, they're congruent, or if you have a circle and you're talking about its radius and its diameter, there's a relationship between them as far as their lengths. Compared to a diameter, how long is a radius? Half. So compared to a radius, how long is a diameter?
Or times 2.
Times 2. Good. So, like I say, a lot of this is not new information, but we need to make sure that you get that. So here's our, in the same circle or congruent circles, the diameter equals 2 times the radius, or you could say the radius is half the diameter. This is a D right here. So the diameter is 2 times the radius, so the radius is 1/2 of the diameter for the same circle or congruent circles. So this is actually the same circle, just reproduced. So we should think through some possible problems on that. I'm not changing it yet, I'm just bringing down the next thing. So if you have a diameter of 4, I forgot to erase these. If you have a diameter of 4 centimeters, you find the radius by doing what? Dividing by 2. So if you know the diameter, you can find the radius by dividing by 2. Let's see if I can get this eraser to erase quickly enough to get this one off of here before it's off. Here we go. That's not too bad anyway. Okay, I just read it down. Good. All right. So here we go. So the radius is 2 on this one. This one, here. If you have fractions, sometimes that confuses people a little bit. If the diameter is 1/16 of a foot. Okay, now here we had, the diameter was 4, that's easy, you divide. But how do you handle this one?
You multiply the denominator by 2.
Multiply the denominator by 2? Good, you're really taking half of the diameter, so it's really, if you write it out so you don't make a mistake, a common mistake when you have fractions is to just divide the denominator by 2, but it's 1/2 times 1/16. So it's 1/32 foot. Yeah.
So simple.
Because it's times 1/2. A radius is half of the diameter, even if it's a strange looking number for the diameter. And so a diameter is how many, is 2 times the radius. So if you're given the radius, you find the diameter by doing what, Preston?
Multiplying by 2.
Multiplying by 2.
But
So,
then I see what you did.
so 3 square root of 2 times 2 gives you how much?
9. 2.
That-
How would you
Wait,
do
you're
that?
doing to the second power.
Oh wait, no.
We're just multiplying by 2.
6.
6.
2? Like how would you do that?
6 times the square root of 2.
But then it wouldn't have to be 2 because 2 times 2.
Nope, that's it.
That's what
I think you're making it too complicated. I think you're trying to square it,
Yeah, that's what I'm saying.
but we're really just multiplying it by 2. Multiplication is commutative, so you can multiply in any order.
So simple.
So just the 2 times 3 is the only simplification that you need to do on that one. Okay, so it's very easy, especially after you've been doing some complicated math, to try to take something simple and make it harder than it is and get wrong answers. So be very careful. All right. Let's keep this up for a second. I think I just want to do a whole brand new picture for the next one because I don't want too much to show up at once. So that takes care of when you have segments in a circle. But there's also lines that can sometimes intersect a circle. Okay? If you have a line and it's going to intersect a circle, it can either intersect the circle in 1 or 2 points. Okay, so let's do a brand new thing. I'm going to get a brand new circle here. So just draw yourself a circle and put a dot in the middle. Yeah, usually we'll get the dot in the middle. This will be. We'll do that now. So this is O is your center point. So this is circle O. Circle O.
That one's about to
Yeah. Okay. Yes. You really shouldn't at this point unless you're desperate.
So simple.
Okay. So circle O.
yeah.
Okay. Okay. Rate yourself, guys. Told you you're desperate. That's fine. Rate yourself, guys. I'll sign in. Shh. Rate yourself.
What is it? What's there?
Okay. All right, so this line intersects the circle at 2 points. That's very similar to what we were just talking about. What we were just talking about that intersect the circle at 2 points.
A chord.
Oh, but that's a segment, right? This one's different. This is a line. So if you have a line that intersects 2 points of a circle, it has a different name. It's called a secant line. A secant line. S-E-C-A-N-T. It's a pointer. Secant line. And a secant line is it is a line that intersects a circle at 2 points. No, it still would be a secant if it was the line that goes along the diameter. It would still be called a secant.
It's special.
Yeah, it would be a little special, but so it intersects a circle.
It's a different 7.
It's either going to not intersect the circle at all, or it's going to intersect at 2 points and be a secant. Even if you had a line, don't draw this, but even if you had something that looked like that, that would still be a secant, because remember, lines go on forever and ever. So the fact that it would go ahead and run into it here would still make it in the secant category. Okay? So you have a secant line. What's the other option? Either not intersect at all, or it intersects in 2 points. What else could happen?
Can it cross each other?
1 point. Well, you could have another one that crosses it, yeah, but it would either intersect the circle at 2 points. It can possibly, you could have another one that intersects only at 1 point. And if it intersects only at 1 point, it has another special name. Okay, now, the word is the same as a word we used for something else, so that's what makes it slightly confusing. But it doesn't have to be very confusing. This line is called a tangent line.
Oh no, I do that.
A tangent line, but we're not doing the SOHCAHTOA things on this, it's just a name.
Why did they do that?
A tangent line.
Another name.
Hold that explanation for another course. Okay,
Okay.
because it would take too long. A tangent line, so it intersects the circle at just 1 point.
Just one. So simple.
Okay, intersects at 1 point. Intersection. For intersecting the circle.
Spell that. Sorry.
Okay? Now this point has a special name also. That 1 point where it's attached, where the line touches the circle just one time, is called the point of tangency. Well, that's why we have a whole lesson on vocabulary. Because a lot of these things, like radius and diameter, you're very used to, but some of them not so much. Okay, so it's not a matter of it being difficult, it's a matter of learning the words. Alright, so we've got the point of tangency where the tangent touches the circle. You've got the secant line. There's no special name for these 2 points, but it does hit it at 2 points. Or possibly a line might not intersect the circle. Okay, let me just double check and make sure I didn't miss anything. No, I did. Okay. I want to redraw a brand new picture for that too, because I want you to see one thing at a time. Okay.
So simple.
So let's do a brand new picture. Don't worry about that. I just want to do this. There we go. Brand new picture. Now, if you have 2 circles, right, I'm gonna move one of them in a second here. We have 2 circles. You could have a line that is tangent to both of the circles. Okay? And a line that's tangent to both of the circles at the same time would be called a common tangent. Okay? That should make sense. If something is in common, it means it's shared. So it's a common tangent if it's tangent to both circles at the same time. So let's just draw in one type of tangent. There's actually going to be 2 types of common tangents. Let's get one of them. Okay, so you might have a line that is tangent to one of them. It comes along, it hits one, and then it hits the other at its one point. And this would be a common tangent.
Yeah, good job.
Yeah, earlier I had to do some
Good job.
adjusting, so I'm glad that that worked out well. So there's a point of tangency on this circle, there's a point of tangency on this circle. This is called a common tangent because it's tangent to 2 circles. But it's got another name too. This one is actually what we call a common external tangent. Common external tangent. Sorry about that.
Not so simple anymore.
No, I just tripped.
Sorry about that.
Okay,
Yeah, me more than most people.
I'm just good at it. It's coming. There we go. Common external tangent. So common because it's for both. External, well, I'll get to what the external part means in a minute. Okay, so we have a common external tangent. If we have an external one, it means that we probably have an internal one. An internal one will actually,
It's on
this
the
one I don't know,
inside, probably.
it goes basically between the 2.
On the inside.
That one I'm going to have to adjust a little.
Alright, well,
But you can draw it better than
Just
that.
simple.
just
You're better
Just a
than
little.
that. So I'm just going to adjust mine a little. There we go.
I can't do that on my own.
No, you can't, but you can draw it, you can kind of bend your line a little
I can
bit.
do all.
There we go. So this one is also a common tangent because it's tangent to both circles, but it's what we call a common internal tangent.
It's not bad file.
That's better. Cute.
Okay, so now it might be that you can just look at these and tell by like glancing at them which is the internal and which is the external. But there is actually a definition for a common internal and a common external. So that's where that's why the diagram looked so confusing at the very beginning. Each one of these circles has a center. So let's say this one's circle Q and this is circle P. Circle Q and circle P. The only reason I'm writing their names up here is because that means that it identifies Q as the center and P is the center. So that's just my little technical thing that I put there so that when I look back at the notes, there's not something technically incorrect. All right, so if we would draw a segment connecting Q and P, I'm going to do it as a dashed line, but I want to draw a segment connecting Q and P. And this is going to be how you can really tell if it's internal or external, although most of you will just say, oh yeah, I can just tell. All right, so segment QP. If the common tangent intersects segment QP, then it's a common internal tangent. If the common tangent does not intersect segment QP, it's an external tangent.
Yeah.
Okay, so that's more of a technical way of putting it. So a common internal tangent will intersect the segment connecting the centers, segment QP. The common external tangent will not intersect. And that's how they give a much tighter definition than we'll just look at them. They look like they're internal and they look like they're external, which they do. But this is how technically you're supposed to tell. They do not intersect segment QP. Yes? All right, so the next thing we need to talk about is that congruent circles. I don't want you to write all that all at once. Okay, don't let it worry you when there's a whole bunch of words. Let's do a little bit. Congruent circles are circles with equal radii. Congruent circles are just circles that have equal radii. They're the same length. So you've got two circles are the same. You can tell by measuring how long the radiuses are, or radii. Okay, so that's the first thing. Okay, circles. If you draw two circles, either they're not going to intersect, or they're going to intersect in one point, or they're going to intersect in 2 points. Okay, if you draw two distinct if you draw two distinct circles, they will either intersect in no points, 1 point, or 2 points. So we need to explore that a little bit. Okay, two circles may or may not intersect. Here are the options, and that's what we're going to draw in next. And I'll make a whole brand new slide so you see them one at a time. Okay. So let's get some options down. The first thing, I'm not sure I can remember very easily because I'm not sure what slide it was. There's just options. Two circles may intersect, and here are the options. I'm more interested in knowing what can happen with that. All right, so let's okay, first of all, they may intersect in 2 points. Okay, oops.
Well, that's cool.
Let's get a
Q to
circle
Q,
that's
right here. Artist might.
solid line. Okay, so we have two circles may intersect in 2 points.
Circle.
That's not what I wanted to do.
It's like a snow.
I wanted them to intersect in 2 points, and I forgot. Because they wouldn't overlap because of the way it was doing. Okay, I gotta be able to not draw it opaque like that, so it was just covering up part of it, so you couldn't see the two circles. So there's the two circles. That's the only one I can't draw with this tool until I figure out one more thing, and I can't find it on there. So here we've got two circles. They intersect in 2 points, so possibly that might happen. 2 points of intersection. Okay? Another thing that may happen is if they intersect in one point. Now, what happened when a line intersected in one point with a circle? We call that what?
Say the question again. Or
If a line intersected a circle in one point, we call that line tangent.
tangent.
Good. So we have, just like you had internal and externally common tangents, we also have internal and external tangents for circles. So let's say one possibility is you could have one circle and it might intersect a second circle at one point on the outside. Okay, so these circles would be called tangent. So for one point, this one happens to be external tangent.
What would the top one?
There's no special name for them, they're just when it intersects in 2 points. There's another thing that might happen. What do you think, if this is externally tangent, what do you think would be internally tangent? How would the second circle be drawn if it was no, that would still be on the inside. Yeah, if we drew a circle inside and it were there and it intersects at just one point, this would also be tangent. So it also intersects at one point and it's internally tangent. Okay, so both of them are tangent. These are points of tangency once again, because it's the one point where they intersect. So we have a 2-point intersection possibly, or a 1-point intersection. You might also have 0 points of intersection. So you could have 2 circles that don't intersect each other at all. These are 0 points. There's no special name for it, but 0 points intersect. But there's another way that 0 points can intersect also. You could have one inside the other. Okay, I've run out of space, so I'm going to need another page for that. Okay, so let's get rid of the page. So you could have possibly one and one that's just kind of in there somewhere. That's also 0 points of intersection. But then there's a special case. And the special case is when the 2 circles share the same center. Okay? If this circle and this circle share the same center, let me move it so that it actually looks like they do. There we go. Okay, each one of those would be called circle P, wouldn't they?
Yes.
Okay, because they both have the same center, but they're not even congruent, but they have the same name. So that's kind of a little bit weird, because you've never actually had a geometric figure before that had the same name that was actually completely different. These 2 circles are what we call concentric. Concentric circles. And concentric circles are circles that share the same center.
Wow.
Usually you think of it like a bullseye.
Right.
And as we go through the chapter, we'll discover a couple of important things about concentric circles. Sharing the same center, so that's important. Now, each circle has an interior and an exterior. Interior would be inside and exterior would be outside. Okay? I'm not taking the time to write that down because it's so natural. But there are a couple questions in your book about the interior and the exterior, just so that I said it once. Okay, so that pretty much wraps up what you need to know for this particular section. Your assignment will be to